Algebra 1, Chapter 1, Section 5, Solving Equations with Variables on Both Sides. So there's three different examples we're going to be looking at. We can look at one that actually has a solution where it comes out to be, let's say, x equals 4. There's another one we could look at that actually has no solutions, where there's not a number we can plug in that will make the equation work. And then there's an equation that has infinite solutions where it doesn't matter what number we put in, it will always work. And so I'll show you those three. So let's start with, let's go with 3 times 3x plus 4. And we're going to say that equals 1/4 times 3x plus 56. Or excuse me, times 32x plus 56. Okay, so we're going to get rid of that fraction over on the other side. We're just going to take 1/4 of everything. So basically, we're dividing by 4 and dividing by 4, or multiplying by 1/4. It's the same thing. And I'm going to go ahead and do this distributive property. We're going to get that all taken care of in one step. So that's going to give me 9x plus 12. And then on the other side, 32x divided by 4 is going to be 8x. And then 56 divided by 4 is going to be 14. And so now we have 9x plus 12 equals 8x plus 14. I always like to combine the x's first if possible. And my rule, and you don't have to do it this way, but 9 times out of 10, it keeps you from having huge negative numbers. My rule is take the smallest one to the biggest one. So if I identify my x's, and I've got a 9x and an 8x, I have to move one of them. So the smallest one is going to be the 8x, so I'm going to move it to the other side. Now remember, I am moving the entire 8x. In the last section, I was moving just the 8, and so I would divide by it. But to move the entire thing, I'm going to subtract 8x from both sides. And the reason I do that is because 8x minus 8x is 0, and that cancels it to the other side. So now that leaves me with x plus 12 equals 14. And now it's just like Chapter 1, Section 4. Actually, this is like Chapter 1, Section 3, the simple equation where it's just one step left. I have a plus 12. To move that to the other side, I'm going to subtract it from both sides. And that gives me a value of x equals 2. So this is the equation where it just has one value. What that means is if I substitute 2 back into the original equation, that is the only number that will solve it. What does that look like? Well, if I take 9 times 2, and then 8 times 2, then in the check portion, this is going to be 18 plus 12, which is 30. This is going to be 16 plus 14, which is 30. That is the only number that will come out checking it properly. So now let's look at the two other ones that we spoke about. I'm going to have one that comes out to be no solution, and I'm going to have one that comes out to be infinite solution. So let's look at the no solution. So I'm going to go 3 times 5x minus 2, and I'm going to set that equal, 5x plus 2, and I'm going to set that equal to 15x. Again, I've got variables on both sides. On the left side, I've got some distributive property, so I'm going to draw my stupid arrows, and that's going to give me 3 times 5x, which is 15x, and then 3 times 2, which is 6. Now, what you're going to notice here is you have the exact same thing on both sides. So I don't have a smaller one that I can take. I have to take either one. If you have 15x on both sides, all you have to do is just subtract 15x from both sides, and now you're going to see something that hasn't happened to us yet. This cancels. This is 6, And then on the right side, 15x minus 15x is actually 0. So I don't even have any x's anymore. And is 6 equals 0 a true statement? Of course it's not. So this does not exist in any form of math. 6 does not equal 0. So there are no solutions to this problem. There is not a number on the number line that you can plug into this equation that will make it true. So let's look at our second value. Some of you might be thinking in your head what that's going to look like. So let's go negative 2 times 4x plus 1. And we're going to set that equal to negative 8x minus 2. Again, we're going to check that parentheses, get that taken care of, drawing the stupid arrows every time. Yes, you have to continue to draw your stupid arrows. Negative 2 times 4x is negative 8x. And negative 2 times negative 1, or excuse me, negative 2 times positive 1 is negative 2. Now, what do you see? You see the exact same equation on both sides. So I could go through this. I could add 8x to both sides. I don't have to, but I could, and that cancels them. And then you get a value of negative 2 equals negative 2. And that is true all day long. I don't know why it keeps doing that. I must be doing something wrong with my pen. So that's true all day long, which means, there it goes again. I'm just going to keep going this time. So if it comes down to be the exact same thing at the end, then your answer is infinite. Solutions. Which means I could plug in any number to that equation and it would come out to be true. So you could have one solution, you could have no solution, or you could have infinite solutions. And that is Chapter 1, Section 5, Solving Equations with Variables on Both Sides.